entrepreneur, or if you're kind of thinking about developing innovative products, where you really want to be is here in the middle. This is really kind of where you have the sweet spot. This is actually when an innovation or a new technology gets possible for the first time. Actually, this is where you want to be, because this is the place where you get the biggest return, right? You want to be the first one. So if you're too early, I mean, you're still in the space where something is impractical, right? You just cannot do it. If you're too late, basically you miss the boat. So this is why you really want to be in the middle, and timing here is really critical. And what we talk about when we talk about digital prototyping, in essence, it's really kind of helping to move from impractical to possible faster. You want to be the first one, right? So when something gets close to be possible, you want to be the first one to jump that hurdle. And this is kind of what we're trying to help with our digital prototyping solution. Now, I mean, for hundreds of years, people are building physical prototypes, right? Only since about 20 years, I would say, people have the possibility now to build digital prototypes. And when you think further, it's only about probably 5 years since we have the possibility to really analyze and simulate these digital prototypes, really kind of to understand how the product will kind of perform in the real world. That's quite interesting. And when you think about digital prototyping, one important aspect of digital prototyping is visualization, right? And when you think about visualization, it can mean things like avatar. So actually, as I mentioned before, the same visualization technology that is used in avatar is also used to visualize huge infrastructure projects, or to visualize high-speed racing cars, or to visualize consumer products. It's all the same technology in the end. Actually, there are automotive companies who are using basically this motion capture technology, which are used in these movies, to basically have their customers or have their people experience new cars, for example. So, therefore, visualization is an important aspect. But when you think about digital prototyping, it's actually the more important thing here is the ability and the capability to simulate and to analyze basically what is being built in order kind of to reduce the material used, to optimize the design regards energy efficiency and things like that. So therefore, I mean, when you think about designers basically have to make trade-offs on an ongoing basis, right? And our objective is really kind of to give them, let's say, the tools to really understand what this trade-off means, right? So to understand kind of what they're doing. So, for example, this is kind of an analysis of the daylight analysis within the interior of a building. So, we're using tools like this one, for example, which really allows you to analyze, a building in regards to daylight effect, or you can analyze acoustics of a building. You can analyze basically the energy consumption of a building. You can analyze whatever the CO2 emission of a building, footprint, CO2 footprint. All these things are available today. The trouble today is, if you ask basically an average architect today, right, what the impact would be on his building if you rotate the building by 20 degrees, or if you were, for example, would basically increase the overhang, or if you would change the material, what is the impact on the energy use? So what's the impact on the CO2 emission and things like that? I mean, most of them, they wouldn't have a clue, okay? Using digital prototyping really gives them that clue. So if somebody really uses the technology here, they can give you really kind of a quality answer to all these questions. This is why we're very strong on this. So here, for example, you see an analysis of a process which we call rapid energy analysis. So this is basically a process which is used also for existing buildings when you think about retrofit. What they actually do here is they take a camera, they take photographs from the building from the various sites, right? And you have digital photographs. These digital photographs, they get stitched together to a 3D model, and then they add some material data to the various pieces, to the walls and things like that. They tell the system kind of where the building is based, and then you basically get this type of analysis. You get an overview in terms of the estimated energy used. You get an overview on the CO2 emissions and all those kind of things. So we actually kind of did this for our own company. We analyzed most of our office buildings, and based off this intelligence, you can start meaningful measures in order kind of to reduce CO2 emissions and things like that. Now, here's another interesting concept. So when you think about digital prototyping really also allows you basically to quickly iterate through various design options, right? When you design something, of course, you want to have kind of look at different alternatives and things like that. So, and one great source, and this is why I put it here, of getting new design ideas is actually nature, or something which is called biomimicry, right? So it's about really borrowing ideas from the nature, looking what nature is doing, and then trying to use these concepts in new products or new projects. So what you can see here is a bird. This is a kingfisher bird, and on the bottom you see a high-speed train. This is the Shinkansen high-speed train from Japan. The thing is, the issue was here, and the challenge the engineers had is when this train was entering tunnels, it was making a very loud noise, like boom, right? So they were actually looking then at the kingfisher bird and looking at how this bird is entering the water. And this is basically how they ended up with the design here. And actually it worked, right? Another example I just put here from the biomimicry area. This is basically a Velcro. Velcro is this, this interlocking nylon zips. We have them in jackets, right? Next to the plant that inspired the inventor. So it said that the inventor came across the idea when he was basically cleaning his dog. He was taking some burrs from the fur from the dog. And so this is how they came kind of to this design here. So the story is really new design, but also time-tested design can be further improved just by better understanding what you're doing. And this is kind of why we're suggesting kind of to use these type of things. Now, today, or these days, there's a lot of talk about cloud computing, right? And cloud computing, I think will be a great thing, a big thing for us, right? It will completely change the way probably also how we do design today. I mean, just when you think about computing today and compare it to about 10 years ago. So today it's interesting. Today you get 10,000 times more computing power for the same price than 10 years ago. That's a lot. But we think that cloud computing will make an even bigger difference. So cloud computing will completely shift the way people are going to work. And cloud computing is actually kind of a shift from something you own to something you're using. But we think the change will not only be because it's based on price and performance. It will be, even though I think that's very interesting as well. So today when you look at cloud computing, 1 hour of cloud computing today costs about 20 euro cents. Okay? So when you park your car downtown Rotterdam in a parking spot, basically you pay probably 10 times more, or 20 times more. It's very interesting. But the thing is, I think we're expecting that computing pricing actually over the next 10 years will probably go down close to zero. It will almost cost nothing. And the change, what we think kind of is going to happen in the design area is that we will not only use the computer to test our design. Today we build a digital model, and then we put it into the computer, say, okay, test it, do a finite element analysis or do whatever analysis. I think the big change that's going to happen is we're probably going to use the computer to make our design. Okay? So what you can do is, when you have infinite computing power, you basically define an experiment, give certain constraints, and then let the computer kind of, build hundreds, thousands, or millions of models, test those models, and then you will come back with the one kind of, which is close to optimum. I think this is what we are seeing is going to be the next big thing. But it's not really kind of, you build the model and then test, so you say, okay, this building needs a very bold example, the building should be between 10 and 15 meters long, should be between 8 and 7 meters wide and whatever, and then kind of you get various scenarios, and at the end, you choose kind of what you want to have.